The idea of traveling through time, especially back into history, has captivated us for generations. Imagine witnessing ancient civilizations or correcting past mistakes. But the moment we consider visiting the past, a major problem arises: paradoxes. The most famous is the grandfather paradox. If you travel back and prevent your grandfather from meeting your grandmother, you wouldn't be born. If you weren't born, you couldn't travel back in time. It's a logical loop that seems to make past travel impossible. For a long time, many physicists believed these paradoxes meant time travel to the past was strictly forbidden by the laws of physics. But theoretical work in the late 20th century opened up some intriguing possibilities. Einstein's theory of general relativity describes gravity as the curvature of spacetime. This theory allows for some bizarre possibilities, including structures known as wormholes. Theoretically, a wormhole is a tunnel through spacetime, connecting two distant points or even two different times. Think of it as a shortcut, like folding a piece of paper to bring 2 points together. While general relativity permits wormholes mathematically, creating or finding one that could be used for travel is another matter entirely. They would likely be incredibly unstable and require exotic matter with negative energy density to keep them open. If we could somehow create or manipulate a traversable wormhole, how might it become a time machine? One theoretical method involves moving one end of the wormhole relative to the other at nearly the speed of light. According to special relativity, time passes slower for objects moving at high speeds compared to stationary observers. If one end of the wormhole is accelerated and then brought back, time would have passed differently for each end. This difference in elapsed time could potentially create a closed time-like curve, or CTC. Entering one mouth of this wormhole and exiting the other could theoretically bring you out at an earlier point in time relative to when you entered. So, what about the paradoxes? If CTCs are possible, does the grandfather paradox break the universe? Physicists have proposed potential resolutions within these theoretical frameworks. One idea is the Novikov self-consistency principle. This principle suggests that if time travel is possible, any actions a time traveler takes in the past must be consistent with future events. You could travel back, but you couldn't actually change anything in a way that creates a paradox. For example, if you tried to stop your grandfather, some improbable event would occur to prevent you, ensuring consistency. Your actions are already woven into the fabric of that past. While theoretically fascinating, turning a wormhole into a time machine faces monumental hurdles. We don't know if traversable wormholes exist. If they do, they'd likely be microscopic. Scaling one up and stabilizing it would require unimaginable amounts of energy and exotic matter that we don't know how to produce or handle. The energy requirements alone are likely far beyond anything humanity could generate. Furthermore, the physics of wormholes and CTCs involves extreme conditions where our current understanding of gravity and quantum mechanics breaks down. A complete theory of quantum gravity might reveal that CTCs are impossible after all. So, can we travel to the past without destroying the universe? Theoretically, general relativity offers possibilities like wormholes and closed time-like curves that might allow it, potentially with built-in paradox prevention mechanisms like the self-consistency principle. However, these are highly speculative concepts residing firmly in the realm of theoretical physics. The technological requirements are currently science fiction, and fundamental physics might ultimately forbid such journeys. For now, time travel to the past remains a captivating idea, a playground for physicists and storytellers alike, but not a practical reality.